All right. This is the last talk of the session. It's an online one, and I think we are almost ready. Can you hear us okay?
Yes, yes.
All right. So we've got Seyyed from University of Texas, Arlington. Can you share the screen, Seyyed?
Yeah.
All right. Fantastic. All right. Floor is yours, Seyyed.
So, hello, my name is Seyyed Mohammad Sadegh Moosavi Khorzooghi. I'm a PhD candidate at the University of Texas at Arlington under the supervision of Dr. Shirin Elizadeh. I'm glad to present our paper examining StyleGAN as a utility preserving face identification method. People upload many photos or videos of themselves or others on social media or YouTube every day, which might endanger their privacy or safety. Moreover, prior research shows that people are concerned about this and they would choose the identification methods to hide their identity if they had access to any of them. So blurring or pixelation have been used frequently to hide faces, but recent research shows that AI methods can successfully re-identify or even reconstruct some blurred faces. Moreover, if you want to have public datasets of faces to be used for applications such as expression or activity recognition, blurring might not be suitable because it blocks the details we need. For example, if we blur the child face here, the activity which is brushing teeth might not be recognized. That's why the utility preserving face identification methods have been proposed. Here, by utility, we mean non-identity related facial features such as expression, gender, age, and pose. GAN-based methods are the most popular ones in this regard. There are many GAN-based methods. Two state-of-the-art with source code are deep privacy and StyleGAN. These methods are proposed to keep pose. You can see two examples of each that the pose is preserved in the de-identified face. So these methods try to preserve pose. What about other utilities, such as expression or age? Do they generate natural photos? Here are some examples that show they might not preserve all the utility, or the generated face might not look natural enough, especially for StyleGAN. So the state-of-the-art methods still have limitations. Style transferring has been used by artists and designers globally to create artistic work based on existing styles. For example, you can see in the above figure that the style of a painting is transferred to a picture, or in the bottom figure, the style of different small faces are applied to the first face. So the question is if this style transferring can be used for face identification. For example, if we consider utility as style, can we transfer the utility from the face to its de-identified version? So StyleGAN is a very popular style-based generator, which generates a new face by mixing the styles of two faces, which are source A and B in this example. Each column inherits core styles from source, such as the shape of the face or gender from source B, and the rest from source A. So maybe if we consider utility as core style, we can hide the identity of source B or the target by getting help from source A or the auxiliary face. So let's see how StyleGAN mixes sources A and B. We need the corresponding Latin vectors ZB and ZA that are mapped to WB and WA. These Ws can be used to transfer the styles at 18 locations in the StyleGAN generator. Cursor styles are related to the top blocks. In this example, the mixed style face has styles from 0 to 2 from source B or the target, and the rest 3 to 17 from source A or the auxiliary face. Here are 4 examples of generated faces for 9 mixed style levels from 00 to 08, and also for deep privacy and StyleGAN. Each row is one example. Mixed style faces for 00 and 02 are too different from the target, while 06 to 08 are too similar to it and seems to have the same identity. Therefore, the middle one, 03 to 05, might be the best choice because the identity seems different while enough utility is preserved. So we performed a thorough analysis for both privacy and utility preserving from both machine learning and human perspectives to investigate the effectiveness of the identification methods. This work is the first one to give such a thorough analysis. All the previous works have done either machine learning or human analysis. We implemented verification and identification attacks for privacy and attribute analysis and face detection for utility evaluation. We will talk about the methods used later. We use the privacy and StyleGAN for comparison. In the verification attack, the attacker needs to verify two faces where one of them is the identified. The verification system, which is Face++ here, gives a confidence score showing to what extent the two faces are of the same identity. To verify, we need a threshold there. The identification success rate, which is 1 minus TPR, shows the effectiveness of the method. Here is the identification success rate for different confidence thresholds for the verification attacks. StyleGAN 00 to 02, 03 have higher rates than deep privacy and StyleGAN. Deep privacy is only a little better than 04, while both are far better than StyleGAN. In the identification attack, the attacker needs to determine the identity of the de-identified face by assigning it to any of n class of identity in the dataset. If the identification is effective, the TPR or accuracy should be low. We use FaceNet to extract unique features of each face as a vector to be used to classify by support vector machines. To implement the identification attack, we assumed a powerful attacker who knows StyleGAN and how to use it to generate photos to train his system. We considered 7 threat models where the attacker might or might not know the styles and the target or auxiliary photos that are used to generate the identified faces. Here are the accuracies or TPRs for different threat models of the identification attacks, like in verification. StyleGAN 00 to 03 have lower TPR than StyleGAN anti-privacy, which is around 30%. For utility analysis, we analyzed 8 attributes using Face++ for gender, emotion, eye, and mouse status. Preserving rates are showing, while for age, smiling, head pose, and blurriness, the mean and standard deviation of the value differences between the original and the identified version are used. You can see the rates from StyleGAN 03 onwards are better than StyleGAN anti-privacy, especially for emotion. So in a nutshell, there's a trade-off between utility and privacy. For privacy, StyleGAN 00 to 03 perform better in both verification and identification attacks. For utility, StyleGAN 03 onwards were better. Thus, StyleGAN 03 is the best choice in both privacy and utility preserving. We can pick StyleGAN 04 if we care more about utility, because the privacy was only a little better in privacy. An effective face identification method should also hide the identity from humans' eyes. Therefore, an IRB-approved survey asking Amazon MTurk workers were developed to see if they prefer the methods, or if they can verify or identify the faces, or if they believe that the identified faces preserve utility. Here, picture X is shown asking if the participants want to hide the identity of the man and woman in the background, what is their favorite order of face identification methods, which are replacing, removal, blurring, or emojis. Replacing was the most favorite one, and the participant reasons mostly were around being normal or natural, or no one notices someone's face is hidden. For verification question, 2 faces were shown to the participants, and they were asked if they could identify them as the same person. We considered 12 verification questions, 2 scenarios multiplied by 6 conditions. For the scenarios, the 2 faces could be from the same person or not. We calculated hit rates when they were the same person and correct rejection when they weren't. We also considered 60 identification conditions, which were 5 methods, and as this condition where none of the photos were de-identified. As you see in the hits, all the methods have significantly lower hit rate than as is for the verification. StyleGAN 03 and 05 also had significantly lower hit rate than the privacy. For the identification questions, we asked to determine the identity of X by choosing from 4 face choices or none of the above. Here, the choices were clustered to have similar attributes to follow the police lineup. To say, again, all 5 of the methods had significantly lower hit rate than as is. StyleGAN 03 and 04 and the privacy were significantly better than Seyyed this time. To test utility preserving, we showed pairs of original and their de-identified versions for the 5 methods and asked if the participant agree on preserving certain attributes or looking natural. There wasn't much significant difference among the methods, only StyleGAN 05 performed significantly better than some methods in preserving expression, pose, and naturality. The participants also believed gender and pose are preserved better than expression, age, and naturality. So in conclusion, we performed a thorough analysis to know if StyleGAN or style transferring can make effective face identification. The answer is yes. From machine learning standpoint, we found out StyleGAN 03 is the best choice and performed better in both privacy and utility than the state-of-the-art methods, the privacy and StyleGAN. From humans' point of view, all the identification methods could significantly hide the identity, and their performance were similar in utility preserve. Thank you for listening to my talk.
Thank you, Seyyed. Any questions in the room? You may shout the question. I'll actually repeat it here, or just come over here. I think we need to speak to the mic here.
Hello. I was wondering for the different threat model you present for the attacks, when you say that the attacker has access to different style level, does the attacker also have access to the latent vector, or could we imagine a threat model where the attacker can project back from the image space to the latent space and then try to re-identify the observation from the latent space?
So that's a good question. We consider that they know the target photos or the auxiliary photos. If they knew the target photos, they could use an encoder to generate the latent vector of the target, and also they needed to guess the latent vector for the auxiliary face because the auxiliary faces were random latent vectors. So we consider if they knew the latent vectors of these photos or not.
Thank you very much.
No problem.
Any other question? We've got time for one last one. So I might have a very quick clarification question for you, Seyyed. Are you generating a set of images across the different experiments that you've got, as in different sets of experiments and different sets of images for the utility, the re-identification part, and so on? Or are you just playing this with a single set of images? It seemed to me from the results you were showing that some of them, in terms of utility, were not great, and so those set of images would be really obvious for the re-identification sort of questions for the mTurk users, for example, but they would not be that great for the utility sort of answers.
So
the question is, did you use one set of images across the different parameters or different sets of images?
So we had 20 auxiliary photos to mix with, for example, 5,000 target photos, and they were chosen randomly. The mixed photos were chosen randomly to show to the participants. So we didn't have any control of the auxiliary photos to have the same utility as
I see. Okay.
the target.
Okay, it's all random. Fantastic. All right. Let's thank Seyyed again then, please.